Hello everyone, today we will discuss about potentiometer. So potentiometer is an instrument which gives us the exact value of EMF. The value of EMF we can get by the voltmeter also, but the difference is that voltmeter does not provide us the exact value, because in the circuit when voltmeter is connected, so it draws some current. So because of that, the value provided by the voltmeter is not exact in comparison to the potentiometer, in which we use the null deflection method. So that is why potentiometer is preferred over voltmeter. Now this is the circuit diagram for potentiometer. The apparatus for potentiometer which we use in lab is like this. You will see a wooden board on which 4 to 12 meter wire is connected. 4 to 12 meter, that means 400 to 1200 centimeter wire is connected by two terminals or two binding screws, you can say, and they will be like in the form of a strips. They are connected like 1 meter strip will be connected, so 12 strips will be there, or it will be like this. So you will see the wires like this, they are connected like this, and here will be the two terminal A and B, and there will be a scale also to note down the length when you touch the jockey on this wire. So through these two terminal we connect the rest of the instrument. Clear? The wire which is used in the potentiometer is made up of constantan or manganese, because they have the high specific resistance and low temperature coefficient of resistance. I already have said before in the last lecture also. So with the increase in temperature, their resistance does not vary. So this is the actual apparatus of the potentiometer. So when you will do the experiment, you will see the apparatus. Now the circuit diagram is like this. AB is the wire, so A at and B end. This is the battery, key, rheostat. They are connected through A and B in this way. Positive of this battery is connected with A, negative is connected with key. Then this key is connected with the rheostat. Rheostat second end is connected with the B point. Now from this A, a cell is connected whose EMF is to be find out. Positive of it is connected with A, negative is connected with the positive of the galvanometer, and negative is connected with the jockey. So this is the complete circuit diagram. Now when the key is closed and the current will flow in this circuit, so current will flow in the direction from A to B. With the flow of current in this wire from A to B, there will be a fall in potential. So this fall in potential per unit length of the wire is known as potential gradient, which we represent by K, and K is equal to your V by L. So K is V by L. So it will be volt per meter, or it can be volt per centimeter. So this is the potential gradient. Now when we touch this jockey, suppose we touch this jockey at this point J1, we need to find the null point. In the null point, the EMF will be equal to the voltage of the battery. In that case, we'll check the length and we'll note down the value. So what we have to do, first we will touch this jockey at this point J1. So when we touch this jockey at this point J1, the potential across AJ1 in comparison to the EMF of the battery is less. Clear? The potential across this AJ1 in comparison to the EMF of this cell is less. So because of that, the current due to this battery will flow along the direction AEJ1, and the current due to this cell will flow along the direction AJ1E. But which one will predominate? Because both are connected with this point A, positive terminal of this battery and cell, both are connected at this point A. So the direction of the current for the battery will be along this direction AEJ1, and due to this cell the direction will be AJ1E. Both are opposite to each other, but when we compare the potential difference, so the potential difference across AJ1 in comparison to E is less. So because of this condition, this cell will predominate over this potential, and because of that the current will flow across AJ1E, and the galvanometer shows deflection in the left hand side. Clear? Now when we touch this jockey at this point J2, now at this position the potential across AJ2 in comparison to EMF will become more. So in that case battery will predominate over the EMF of the cell, and because of that the current will flow across AEJ2. Now in both the cases we are getting, in this case the deflection is in left hand side, in this case the deflection is right hand side. So that means there will be a point in between these two where we'll get the null deflection. So suppose J is the point where we get the null deflection. At this position the potential from A to G will be equal to the EMF of the cell. Clear? So this is the thing about the principle of this potentiometer, and at this point we get the null deflection, and we note down the length from point A till J. So now that I have written here, when the jockey is made to touch at the point J1 on the wire, so potential difference between A and J1 will be less than EMF E, and in this case current will flow in the direction AJ1E, and the needle of the galvanometer will be deflected to one side, that is on left hand side. Now when the jockey is made to touch on J2, then the potential difference between A and J2 is greater than E, therefore current will flow in the galvanometer in the direction AEJ2, and the needle of the galvanometer will be deflected to the opposite side, that is right hand side. Now when the jockey is made to touch on point J, the potential difference between A and J will be equal to E, and in this case no current will flow in the galvanometer, and hence there will be no deflection in the galvanometer, and the point J is called the null point, just like meter bridge. So let I be the current which is flowing in this galvanometer, means in this wire AB, and rho dash here is taken as the resistance per unit length of the wire. Clear? This whole wire will have some resistance, so suppose rho dash is taken as the per unit length of the wire, the resistance per unit length. So what will be the value of the resistance? It will become equal to rho dash into L. Clear? So if L be the length of the wire between A and J, where we are getting the null deflection, suppose the length from A is L. So the potential difference across AJ, is given by voltage into voltage will be equal to the current into resistance, that is V is equal to I into R. So we know that I is same multiplied by R is replaced by rho dash into L. Clear? As I told you, rho dash will be R by L, so R will become equal to rho dash into L. Now this quantity, since current and the resistance per unit length will remain constant, which is your K, so V will be directly proportional to L, and V will become equal to K into L, and this K is equal to I rho dash is called the potential gradient. That means potential difference per unit length of the wire, that is potential gradient along the wire. Clear? So the principle how we'll write? So when a constant current is passed through a wire of uniform cross section, the potential difference across any cross section of the wire is directly proportional to the length of that portion. Clear? So that means V we write is directly proportional to L, and when we remove this sign we'll get L. So V is equal to K into L, so K will be V into L. Clear? So potential gradient is voltage per unit length. So this is the principle of potentiometer, and in case of null point position we have V is equal to E. So E will be equal to K into L, because V is KL, so here E will become equal to K into L. Clear? Now about the sensitivity. So if on displacing the jockey we get high deflection, much fast deflection in the galvanometer. So in that case we can say that the potentiometer is very sensitive, and the sensitivity depend on the potential gradient along the wire. So smaller the potential gradient, greater will be the sensitivity. Clear? Now we'll discuss about the uses of potentiometer. So it is used to compare the EMF of the cells, and also it is used to find the internal resistance of a cell. So this is a very important topic for your board theory point of view, because in the practical examination potentiometer is never asked, this comparison, and they are not asked mostly in the examination. But in theory paper the circuit diagram definitely will be asked. If you check the 10-year paper, you will find out that most of the time the circuit diagram is only asked. So theory is not asked to write the theory of it. It is in the question, if you will see, it will be given to draw the circuit diagram. So because of that, the circuit diagram is very important. Practice the circuit diagram in rough copy, and that will be asked in 3 marks. So if you will draw the correct circuit diagram and you write the formula, you will get full marks. Clear? So these circuit diagrams are very important. So for the comparison of EMF of two cells, this is the circuit diagram. This is the apparatus of potentiometer. This is the wire. AB is the 2 terminal. This is the scale. Now for comparing the EMF, the two cells which we compare, whose EMF will compare, will be connected like this. From the A terminal, the positive of both the cells will be connected, and negative will be connected by key, and that will be two-way key. We have one-way key and two-way key. So two-way key purpose is that when one side of the key is closed, the other will be open, or the other will be closed, the second will be open. So that is why here we use the two-way key. And this will be connected with the galvanometer. Positive and negative will be connected with your jockey, which you will touch on this wire. Now from this A terminal, a battery will be connected through which the current will flow in this circuit. So positive will be connected with A terminal, and negative will be connected through a single key, that is K1, and through a rheostat. Clear? Rheostat second end will be connected with the B terminal. So this is the complete circuit diagram of this circuit, that is the for the comparison of two EMF of a cell. So the circuit diagram is clear. I hope that is clear. Now what you have to do, so you have to close this key K1, and then what you have to do, first you will make from this two-way key, you take out the plug of this the key through which this E2 is connected. So that means we have to put the plug of this key in such a way that E1 is included in the circuit. Clear? So one, we will include E1 in the circuit, and second we include E2 in the circuit. So one by one, in 2 steps, we will note down the null point. In first case we include the E1, the first cell, through this two-way key, and in the second case we will include this E2. Clear? So we will make E1 open, E2 close. In the first case we will make E1 close and E2 open. Clear? So like in the first case, when K1 is closed and by means of K2, E1 is included in the circuit. So when E1 is included in the circuit, now start touching this jockey on this wire. So when you touch this jockey on this wire and where you get the null deflection, stop at this point, that point, and note down the length from A terminal. So the length you will measure will be like this. Like from here to here it's 100 centimeter. This will be 200, and like here you are getting at 50. So this will become 250 centimeter. Clear? So this is how the length will be measured in the potentiometer. Start from here, initial, it will be taken as 0. So this will become 100, then this will become 200, then this will become 300, then this will become 400. So like that you will measure the length. Clear? So first step is when K1 is closed and by means of K2, E1 is included in the circuit and null point is determined. Now suppose the null point that you will get is at a length L1. So from point A, the length if we take it as L1, so in that case E1 will become equal to KL1. We had seen the formula is equal to KL, where K is the potential gradient. So for E1 it will be equal to K into L1. L1 is the length from A at which we had got the null point. And similarly in the next step we make this E1 open, E2 closed by this K2, and make this E2 included in the circuit, and again we will find out the null point. And when we get the null point, suppose this length from A is L2, so this will become E2 is equal to KL2, divide E1 by E2, you will get KL1 by KL2, so E1 by E2 will become L1 by L2. So from this, the ratio of E1 and E2, if L1 and L2 is known, you can find E1 and E2. And if one of the two cell is a standard cell whose EMF you know, so the second EMF you can easily find out. So this is the method of comparing the EMF of the cell. The most important thing is the circuit diagram. So learn and practice the circuit diagram, and definitely it will come. Second is to determine the internal resistance of a cell. So in this case, for finding out the internal resistance of a cell, we will connect only one cell whose internal resistance we have to find out. And in place of here we had two cells, E1 and E2. When we find the internal resistance, this will be replaced by the resistance box. So here you can see this is replaced by the resistance box. E is the EMF here connected in this resistance box, and this positive of this cell is connected with A terminal, and this whole circuit arrangement will be same. So this remains same. Here only you have to replace E2 by the resistance box. And then what you have to do, again you have from the storage cell you have to pass the current by doing the K1 closed. So in that case this cell will remain open circuit. So in that case the potential difference between its terminal will become equal to the EMF of the cell. So E will become equal to KL1. Clear? Now means when this K1 is closed and this is open, this is not included, and you will make to touch this jockey on this wire. So in that case, when this is not connected, this key is not connected, so this cell is a open circuit. So in that case the potential difference between its terminal will be equal to the EMF. So in that case E will become equal to KL1, where L1 is the length of the null point from point A. Clear? So E will become KL1. Now in the second case what you will do, you will take out a resistance from the resistance box and you will make this K2 closed. In the first case K2 will be open, so this will be an open circuit. Clear? So in the second case you have to do the K2 closed, and in that case a resistance will be taken out from the resistance box, and again you will touch this jockey on this wire, and in this case it will be for the potential V between the end of the resistance box. And now if the distance that you will get is L2, so it will be V is equal to KL2, and in this case E by V will become equal to L1 by L2. So E by V will become equal to KL1 by KL2. So E by V is equal to L1 by L2. We had discussed the relation of internal and external resistance. So R small r is equal to capital R E by V minus 1, and E by V is equal to L1 by L2. So internal resistance will be equal to the external resistance multiplied by L1 by L2 minus 1. So we know the resistance which we are giving from the resistance box, L1 and L2 we will take. So easily we can find out the internal resistance of a cell. So this is the topic of your uses of potentiometer. The circuit diagram, again I am saying this is very important. So learn to draw the circuit diagram in rough copy, because that will give you complete 3 marks if you draw the circuit diagram correctly, because the question which is asked is not about the theory of it to write, it will ask directly to draw the diagram, or sometime it is asked to write the formula. Clear? So I hope the topics are clear to you. If you have doubt, so you can clear your doubt by sending your query on to me on my number. Thank you.